So we're construction, so we can still operate at the moment in Victoria, but unfortunately we have to wear masks. This table's not quite 1.5 meters across, but we'll project and hopefully be heard well. You may also see some flashes behind us. It's not a photography shoot. We've actually got some welding happening in the factory today, which is a bit unusual for us because we're mostly timber. Yeah, thanks Alistair and Wood Solutions. The program of CPD events Wood Solutions provides is excellent, and it's a privilege to be invited to this. We're a design-led prefab builder that has evolved. We actually evolved out of an architecture practice, and I guess because of that, design always comes first with us. We don't like to be pushed around by standard module sizes. From our infancy, there's always been a focus on timber construction because it's a beautiful material to work with. It's practical, and of course, there's very good ecological benefits. Our relationship to ecological sustainability also extends to Passive House. We've completed a number of Passive House certified buildings, and for the uninitiated, that's a benchmark for the, I guess, the highest performing buildings. So a brief outline of what we're going to talk about today. It's three sections. We'll cover an introduction, introducing the main terms of prefab architecture, i.e. benefits, the concepts of design for manufacture and assembly, also designing for transport. After that, we'll look at a lot of case studies, projects we've completed, and we divided them into two groups because we build in a couple of different ways. So the first set will be, I suppose, the traditional modular or volumetric builds, and then will be followed by panelised construction. Introduction to prefab architecture. Off-site construction is a term we often like to use. It paints a clear picture. Since the dawn of the industrial age, there's been a shift in most manufacturing processes towards a factory environment that increases overall efficiency and quality. But the prefab of buildings has been rather late to the party. However, in the last decade, I suppose, it's really taken off. The benefits of factory construction can finally be realised in an architectural prefab building. And they are faster construction, so trades can work on several projects in one place concurrently and keep working when it's raining, like it is today in sunny Victoria. And with that speed and timing comes certainty. So we can keep to program a lot better than a conventional construction mode. Efficiency, try to use standardised parts and construction details where possible, but also just working in a factory environment by its nature is going to be more efficient. And again, there's an increased certainty of cost that we can bring. Quality control, stable environment, so it's much easier to uphold standards of construction. Reduced waste. I guess one way we achieve that is there's two ways. One is by being clever about how we design the building so we can have minimal offcuts of sheets, etc. But also any excess from one project can easily be used for the next one, as long as it's a transferable material. And safety. I've been able to work in an indoor environment where there's safety protocols that are much easier to follow is a benefit. Prefab buildings often compared to the motor industry, where the key drivers were efficiency and quality control. But there are two key challenges in translating this to whole buildings. It's pretty obvious, the first one, scale. Can be a bit of a trick trying to build a large double-storey building inside a factory and get it to site. But then there's also the issue of customisation. And because of these, it's simplest to prefab buildings. Well, it's the simplest way, and I guess for most of prefab history in countries like Australia, prefab buildings have been limited to either being very small, so there's just one unit can be moved to site without connection to another, and if they're exact copies. So, e.g., you get prefab site offices or caravan park cabins, which I think kind of paints a picture in some people's minds of what prefab can be, or all prefab is rather. So the history has led to a perception that prefab buildings have poor amenity and are boring. But maybe that's just an Australian thing though, because for instance, in Japan, prefab is becoming to be seen as a premium product, not something which is less. Prefab construction companies like ours overcome these challenges by building houses and larger buildings in manageable chunks, I suppose, that can be easily transported and assembled on site, shifting away from that Fordist attitude of building exact copies to allowing some flexibility. So if you like, we embody a post-Fordist approach. This allows us and other design-focused prefab builders to produce buildings that break the mould, so to speak, of the production line shed. But despite this, there's still a tendency in some of our projects to, if you like, celebrate the box to produce something that embraces a modular aesthetic, such as the bathhouse project in the top right corner there. Just because we build the most efficient way to build as a box doesn't mean we necessarily have to avoid it. There's something kind of nice and elegant about that. But then another design approach that I guess we're following more and more these days is to blur the distinction of the modular project. Our South Crescent project in the bottom right-hand corner there is actually 4 modules connected together on site, but the integration of some site-based masonry makes the lines between the modules very difficult to spot. We use Prehab to build the projects, but you don't have to let it drive the architecture. We employ several prefab building methodologies and are open to using some site-based elements where necessary, which provides us a good deal of construction flexibility. Now, prefab isn't just modules. I suppose you can consider it almost a spectrum. There's even the most conventional construction really has an element of prefabrication. Windows are prefabricated generally. If your builder said to you, oh, we're going to, in this site-based build, we're going to build the windows on site, you might get a bit nervous. Hang on, is that going to be a good window? Surely you can't. That can't be windows should be made in factories. It's a higher standard of construction. So maybe the same idea could be translated to building whole buildings. Other aspects of regular buildings that are prefabricated, of course, are wall frames, trusses, and even manufactured cladding materials. In conventional construction, the prefab elements form only very little chunks, but there's really a spectrum between this and fully finished modules. Modules can be, such as the one that's being craned in on the left-hand side there, can be more or less finished. If it's just a very simple building that might only be one module, or even a few that are joined up, they'll be tiled, grouted, appliances and plumbing fixtures installed, and ready for mains connection. So really all that needs to happen on site is just pop it on a footing, which can be happening concurrently to the finishing up of that module, so there can be overlapping program. Any other modules stitched together to it and services connected. The next one that so there are quite a few different approaches, but I guess this is the 3 main approaches we follow. Panelised in the middle, think flat pack. Sometimes on certain projects, site access can be very restrictive, where you just simply can't get a module to site. So in this case, floors, walls, and roofs are all built as cassettes. They're broken up into cassettes and assembled and fixed together on site. There's quite a lot of variability with the degree to which we can finish them off-site, but the goal is to do as much as possible before we get to site. So you can see here the one in the middle, the final cladding's not on, but the framing has a building wrap and battens in place ready to go. Often with floor cassettes, they might be lined on both sides. The decision of what size chunks to build is determined by a number of factors. It could be site access or the design itself, but whichever prefab approach is taken, an understanding of design for manufacture and assembly and design for transport is pretty critical, and Ben's going to pick this up now.
Excuse me. Thanks, Andrew. Yes, as Andrew was saying, we think the benefits of prefab are real, but it's not just a matter of taking any given building design and deciding to prefabricate it. The benefits are best accessed by bringing a manufacturing approach to the construction of buildings. And this is where you come across the term DFMA, or Design for Manufacture and Assembly. It's become a bit of a buzzword in the construction industry when talking about prefabrication and off-site construction. So I thought it was worth doing a little bit of a deep dive. It's actually quite a deep topic. So DFMA actually originated in the manufacturing industry, where these approaches have been used to gain huge efficiency in the manufacturing of mass-produced products like toasters and cars and so on. Oh, next slide. And we find with prefabricated building, while DFMA was not created for the construction industry, excuse me, we find that bringing that DFMA type of thinking to prefabricated buildings, we can gain a lot of benefits as well. So this is what that process looks like for us. we produce, detailed 3D models and drawings of the building for fabrication. So obviously in this process, BIM is absolutely critical. So we go through the process of doing a detailed framing model of the project, modelling in all the structural elements and the timber framing elements, and then pulling off a series of framing drawings that are fully dimensioned with cut lengths and angles and so on, that we can pass to our workshop to build the components. Thank you. So this is what that process looks like in our workshop. Now, as the name suggests, design for manufacture and assembly, there's actually two aspects to the concept. Design for manufacture deals with the ease of manufacture of the collection of parts that are used to form the product. In the image here, I've got one of our guys working on building a wall frame, but you could just as easily apply or think of each stud as a part or each module as a part. So there's parts within parts. And the other part, but the other side of the coin with DFMA is the design for assembly approach. And the image here is a module being assembled from the wall panels or parts. Next slide, thank you. So it's a little quick look at DFMA. And the interesting thing is when we take that DFMA thinking to prefabricated buildings, there's another layer that you need to consider. Because unlike manufactured goods, prefab building elements need to be transported and installed on a construction site.
So, yeah, I mean, just looking at these images here, they're nice images, but there's certain, when you interrogate it, you start to think, hey, realise there's quite a bit going on here to consider. For instance, the module that's sitting on the back of the truck on the left-hand side there, the whole module is not sitting on the tray. There's quite a bit hanging over the edge. So that has to be factored in when we're designing these modules or any other building elements to be transported on site. Where's it going to bear on the site? Is there going to be something hanging over, and does the engineering allow for that? And the answer is yes, we always make it happen, but it has to be considered. There's the modules also being attached, so there's strapping going on or attachment points to make sure it's can not roll off when it's turning around a corner. And then looking at the right-hand side image of a module being craned into place. So that building's going to be, the crane has to attach onto it in some way. How's it going to occur? Does the module allow for that strain? And then is that attachment method going to get in the way when you try and land it in sight? So in the next few slides, we'll go into those more pragmatic issues to just simply spatially working with a module or a panelised build. So we've got an understanding of the principles of designing for manufacture and assembly and design for transport. Now we want to build as large a building sections offsite as possible to minimise on-site work. What can you fit on the road is the inevitable question. The adage goes that the width of a horse's rear end dictated the width of a car, the width of a road lane, railway tracks, and even apparently space shuttle dimensions. These dimensions for roads has led to us to a very set of cold vehicle size limits to work within. And I'm pleased to announce it's a happy accident that we can what can be fit within the envelope of an oversized truckload on a standard road overlaps quite well with logical chunks of a residential building. This image here, I think, encapsulates probably what I like to call almost the 10 commandments of prefab construction, what you can fit. It's working at our office here, it's one of the most important things to get a understand straight up. How much can you fit on a truck in one piece? Of course, we've seen images on some of those TV shows about, huge double-story buildings overlapping 4 lanes on one or two trucks being transported down the road. Where there's a will and deep pockets, there's a way, but the reality is this kind of thing is normally cost prohibitive. What's more realistic is utilising the envelope permitted under different classes of legal or oversized truck loads. The diagram here summarises 3 basic strategies we employ. So there's more avenues than this, but we've found from our experience these are the most practical. Basically, with these, the bigger you go, the greater the house volume, but also the bigger cost trade-off. When you, for instance, so from left to right, basically it gets more costly to transport, and also maybe other approvals, and at least definitely with the oversized number 2 down the end there, you need pilot vehicles, etc. Left-hand side is the simplest. I guess think of that as a standard truckload you see going down the road, shipping container type size. We might use that kind of load for panelised construction. You have to stay within about 2.5 metres wide and 3.3 high, so it's not really suitable to a standard module. You wouldn't get a very nice space within that kind of volume, so that's for panelised construction. The one in the middle would be our bread and butter. You can actually fit a good size chunk of house, for instance, and I'll show you an image in the next slide of how this might work, but it could be, say, a bank of bedrooms or a living space can fit quite well into that. Regarding the height, 3.9 metres overall we work to. I mean, we definitely allow a bit of tolerance. Often we'll design a bit less, because you never know, there'll be a bit of flashing or something sticking up just a bit above to drive you nuts when you're trying to get it out the factory. But with that 3.9 metres, if you consider the floor structure might be 300 mil, and then a minimum pitch roof and ceiling could be about 600 mil we might be able to achieve, you're left with 3 metres. So we can, 3 metre high ceilings are achievable within this. And the one to the right, sometimes there might be a need for slightly wider living spaces, say we can go a bit wider. But an important consideration also is that not all sites can receive the maximum oversized envelopes. If a road's very narrow, lined with large trees, crossed by power lines, this can often reduce the maximum load for a particular site. And at early stages, like this ties in quite well with the design for transport concept, is the coordination with the transport company is critical to establish this, because the last thing you want is to have a module ready to go and it's just sitting there at the end of the road, can't go any further. So this is an example here of a floor plan. This is our Lockwood Street project. It's a nice courtyard shaped building, and the red dashes there indicate how the module breakups occurred. And so the bigger ones are at the top and bottom. That they're all fitting into a pretty standard module size. So you can get a full living room, dining, kitchen, and we've even snuck in a powder room, laundry, butler's pantry behind this kitchen in this case. And in the bottom, that module contained 3 bedrooms, 2 bathrooms and a robe and a hallway. So it's a nice accident that this sizes for road transport work out so well for this. And we don't have to be limited to this too. We do a lot of, say if you want a living space that's much, much wider than this. We actually do school projects too, and classrooms are wider than that. And the way we approach that is simply leave off, might be 2 modules and leave off a wall from each one, and then connect them together, maybe leave some of the linings and floor coverings off and do them on site and make it all seamless. And that's the way we can achieve those larger sizes. We can also do the same thing with vertically to achieve double height spaces. And I think Ben will have a example of that to talk about later. And the final slide for our intro is, again, relating to design for transport. Crane logistics is an important consideration too. So you've got it to the site, you manage to dodge all the power lines and the trees and whatever. Then having a crane methodology is an important bit of coordination with our project. So in this example here, we don't do this all the time, but it was pretty critical for this type site. Had to show where the crane would be sitting on the site, where a truck would pull up behind it. Everything has to be planned so that often the boom arm of the crane can be very long. So you need to be able to lift up the module, swing it across and over onto the site. Sometimes we find that module might actually, we try to avoid it, but sometimes it has to pass over other structures. And so there are permits that we must get to do that. And we can thankfully say that we've had a 100% delivery strike rate with modules.
All right, thanks, Andrew. Excuse me. Now we're going to jump into some more detailed case studies of a few of our recent modular volumetric projects. As was sort of already said, the biggest advantage of a volumetric modular approach is it lets us complete the maximum amount of the building work within the workshop, and really minimise the amount of work that we have to do on site. So we're typically doing cladding, roofing and windows, internal linings, finishing and fixtures all in the workshop. The first modular project that we'll look at, and it's probably going to be the main one that I'll talk about, is a recent project we finished in Donvale, the Donvale Passive House. So here's some renders of the building we produced during the design process. The brief was for a generous family home on a large greenfield site. This is the facade of the building that faces into the garden. As you can see, there's quite a lot of glass here and a couple of outdoor living spaces. These are positioned to make the most of the future gardens that the clients planned for the site. Let's looking at the other side of the building, the rear facade of the building, where there are the private spaces of the house, but they also face into the garden with heavy glazing. And here you can see on the roof of the building the highlight windows that are used to bring light deep into the middle of the house. So and jumping to the floor plan, you can see it's a 3-bedroom house with additional space for a dedicated study and a media room. So it becomes more like a 5-bedroom house. When we're prefabricating a project like this with our modules, the first step is to figure out the best way to divide it into the modules. This shows how we did the module breakup on this job. In this case, we designed the main living space to fit just within the large transportable module dimensions and use the same dimensions for the bedroom wing. So that's the blue and the yellow areas there. And then we had 2 smaller modules that make up, the rest of the house, the entry area and the master bedroom. Where possible, we bring the edges of the rooms and module junctions together so that we can have a duplicate wall in each module to support the roof structure, so the modules can be structurally independent. These walls are often called a marriage wall. So there's 4 modules on the ground, and then there's a 5th module that went on the roof, which was for those highlight windows that we looked at previously. So again, as we've sort of looked at already, in order to build these modules away from the site, we produce a precise BIM model of the timber framing. And this is where we've found there to be quite a happy marriage between prefabrication and meeting the requirements of the passive house standard. I don't know if I said before, but this building is built to the passive house standard. So for those that aren't familiar, there's sort of 5 principles, but the main implication of the principles is that you must achieve a really airtight thermal envelope with continuous insulation all throughout. So as we're looking at before, because we model buildings and structure in such detail and looking closer at the sequence of construction, we are really able to analyse that thermal envelope and look closely at the amount of thermal insulation there is, identify any thermal bridges, and ensure those air tightness layers are able to be continuous around the structure. And as an adjunct to that, I guess the use of timber framing construction is fantastic because it really eliminates or reduces the thermal bridging that you can have. So jumping in the construction of the project is the floor framing of the modules taking place in our workshop. So in order to be able to transport our modules and lift them into place with a crane, that we need to make a really rigid base. So we achieve this by using quite deep floor frame members that then support the roof and the walls of the module. The other thing that's important to note here is we try to make a very level interface between our modules and what they land on site. So here's a typical of what we see on site. Our footing system, these are screw piles, but the same principle for other footing systems. We try to make a flat level top to it, and then we drop our modules directly onto it, and eliminate any sort of vertical cleat plates or plates that would stick up and clash with the modules. And the fixing is just done by fixing up from underneath the building once it's been landed. So jumping back to the workshop, so the rest of the walls are timber framed and with some additional bracing to tie it back to the floor structure. This is a passive house job, so we're actually building it with a 140 deep timber frame to get the additional insulation in there that's sort of needed for the passive house requirements. And this is the roofing stage, or the roof framing stage. In this project, we did a trussed roof to make the assembly process as efficient as possible. But on other projects, we do a framed, or more conventional framed roof. It just depends on what's the best outcome for the project. So here we're seeing the highlight window module that I was talking about. we've sort of taken this approach a few times where we stack an additional module on the top of some lower modules to create more space than you could fit within the transport limits for the main modules. So as a quick aside on that concept, we've pushed that approach of stacking the modules to get that internal volume a lot further. On the project you see here, we made quite a large first floor module with an open base that we then stacked on top of the lower modules to create this fantastic two-story void space that you can see in the end there. The red dashed line sort of indicates where the modules were broken up. There, you can see the timbers in the base of the upper module there. They're just for bracing during the transport process. They were removed once it was all landed on site. Yeah, back to the Donvale project, sort of a really great use of timber in the project was Char timber cladding. The Japanese name for it is San Shugi Barn. It creates a really beautiful and low maintenance finish for the timber. Also, as you can see here, the modules are fully clad and windows installed and roofing is done in the workshop. So looking at loading the project up and delivering to site, this is one of the two larger modules loaded for transport. And the smaller modules were loaded on trucks in a similar way. Here's our flying building shot for this project. So important to note here, on most of our projects, we use a bottom lifting approach to install the modules. So the lifting gear runs underneath the module to support it. And here's the roof module landing as well. And the interesting thing with a bottom lifting approach when you have these stacked modules is you have to ensure that the lifting gear will be able to be removed from between the modules once they've landed. So we, as part of the process when we're designing the framing for this, we allow some little pockets or holes where that lifting gear can be withdrawn once the modules are landed. And on to the finished project photos. There's the front entry of the house. You see that beautiful charred timber and offsetting that against some clear finished or natural finished timbers as well. And the use of timber, there was an extensive use of timber on this project, extends to the inside of the house. We're using black butt internally for the flooring and joinery finish. The windows were built from Victorian ash with an aluminium cladding to the outside to make them more weather resistant. A lovely detail that we did of the wine storage racks in the project and the kitchen. Another great use of timber in this project was a solid timber bathtub. It's actually made by a surfboard manufacturer in Byron Bay, I think. It was a very heavy thing, so this actually had to get installed after the modules were landed. To do this, they had to leave the glass out of that window there and bring the bathtub in through the window and put it on the floor. So I think this is the last image of the Donvale project, just looking again from the garden side, the charred timber and then black butt timber external finishes. Obviously, the client has a large master plan of landscape works that are going to be done to sort of nestle the building into the site. Okay, the next modular building we're looking at is the north addition we've done in North Melbourne. So you can see the new addition on the top there. It's an existing two-story townhouse, and the client wanted some additional living space. Given it's a pretty tight site, the solution was really just to add another level to build up. So this wouldn't be an easy build in any context on a tight inner city site. So bringing prefabricated solution offered a lot of benefits. So we could do a lot of the work off-site and just land our building onto it. Another note with this project, using timber frame constructions for our modules allowed the new modules to sit directly on top of the existing structure without having to do additional reinforcing of the old building. So floor plan for the new project, pretty simple, just a lounge, sort of bathroom and stairs and a deck area. Looking how we broke that up into modules. for a small addition like this, you'd like to do it as one single module, but ultimately the width of the plan of the project meant that a single module would be too wide to fit within transport limitations. So the solution was just to break it up into 3 sort of mini modules. You know, the other option would be to try and squash the whole build, the addition, to try to fit it within one module. But as Andrew was saying, we don't let the modules push us around. We try to bring the best solution for the clients that we can. So again, you can see here we're using the internal walls between the rooms to create marriage walls, so modules can be self-supported during transport. And you know, just another quick note with modular construction, it's really helpful if you can keep things like bathrooms and kitchens, where there's a lot of finishing and fixtures, completely within one module, so that you don't have to do any of that work on site. Okay, so more workshop shots of this project being built. Similar to the first project, we've got the rigid floor frame, and the rest of the timber framing is sort of built on top of that. The floor frame provides the support. So these are modules loaded up and ready for transport. Again, fully clad, lined, windows installed, roofing installed. It's interesting to note on this project, you can see in the photos that the cladding is actually lifted up from the base of the modules, as these modules are going to fit within that existing building, and we're just making sure that we can get the flashings from the bottom of the cladding onto the existing roof structure. Make sure it's all waterproof. And here we have another flying building shot. You can see the modules getting nestled in to position on top of the existing building. There's the project nearing completion. Not a great photo. We haven't had a chance to get the photographer to go through there. The last thing on this project was, again, it's just some of the internal detailing where we're using timber as much as we can, is the new internal stair that links up to the first floor addition. So we're pretty excited about this. We've hung the new stairs on steel rods from the new module that sits on top. Then we've got some great solid hardwood timber treads that are going to step down into the existing house. Okay, the last modular project that we're going to look at is a dual occupancy project we recently or nearly completed in Glen Iris. So again, we have some rendered imagery we do as part of the design process. So this is the view from the main street, and it's a three-bedroom townhouse development. Again, we're using timber here with some as a main feature of the facade with this batten cladding on the outside. Looking at the project in section, you can see it's a sloping site, and our building forms are following the slope of the site. So it ends up being a reasonably complex form, and it also means it needs to be a fair amount of site-based works done before we're installing our modules. So looking at how we break that complex form up into a series of modules that can be stacked alongside and on top of each other. And the complexity of the install and the need for fire-rated walls. I'll just jump back. So this is looking at the project in section. The townhouses are mirrored along the centre line of the site with a fire-rated party wall in a pretty conventional manner. So in order to maintain the integrity of the fire-rated wall, we didn't want to do what we normally do, the bottom lifting approach, as we would have to leave holes to allow for the withdrawing lifting gear once the modules are landed. So on this job, we looked at a top lifting approach. This slide's just explaining or showing the difference between bottom lifting and top lifting. So bottom lifting there on the left with strapping and lifting gear that actually goes underneath the module. And on the right, top lifting, where we're actually connecting directly to the top of the module, which allows us to sort of land these much closer together and have continuous finishes in fire-rated walls. So this is a shot of the modules being fabricated in our workshop. And that top lifting approach meant that we had to integrate some steel into the modules that connects directly to that rigid floor framing base. We can see we're still using the majority of the structural framing as timber. So again, our modules were fully clad with windows and roofing installed in our workshop. The modules being loaded up, ready for transport. And here's our flying building shop for this project. You can see that rigging set up connecting directly to the top of the module. And this allowed the modules, to fit very snugly together when they land on site. So as you can see, they came together pretty seamlessly. And this project is also very nearing completion with additional site works and finishing and currently being done. Pass it over to Andrew again.
Thanks, Ben. For the final section, we'll talk about projects where we broke the buildings up into smaller chunks to prefab offsite. 3 examples here: Tucker House, Shoreham, and Berry Street. The reason why, I guess the key driver, as I hinted at earlier, for opting for a prefab panelised approach is largely access. And we've been asked to look at many projects where take one look at the driver, the access, and go, this is not going to be easy to either the road's too steep a grade, like that one on the left there, or there's just overhanging trees, roads are narrow, power lines, etc. It also, the other advantage it offers too is, even though a modular approach can give us quite good heights, you can get 3 metre ceiling heights. If there's a desire to go higher, there's an increased flexibility there. With a panelised approach, you can build those walls as tall as you like. It's an approach that's somewhere between fully offsite and fully on-site, and there's still significant advantages to gain with the amount of prefab that occurs in a panelised construction to warrant it as a process. Tucker House. Here's Tucker House, Wye River. We've done quite a lot of projects in Wye River and gotten to know the personality of that place pretty well. There are a lot of challenges to deal with in Wye River. Firstly, the roads are very steep. You can't get modules up there to deliver a modular approach. And why do people come to us in the first place for these sorts of locations? And I suppose it's that as soon as you get out of the metro area and parts like this, it can be quite challenging to find a builder who's willing to go out there for 12 months to slog away at building a house. And it might cost more than, say, a metro project because the builder has to cover themselves. So the more you can do offsite, the better. So prefab becomes a viable option in places like Wye River. Wye River also has landslip risk issues. So all our projects there end up having, conventionally we'd have a screw pile type system, but here you can't do that. We generally opt for, well, with the guidance of consultants, ends up being something like a board pier system with a steel frame holding up the floor. It's also a bushfire risk area, so the projects are either generally BAL 40 or BAL FZ, which is something that we can achieve quite easily. Sometimes we get questions about, hey, is timber framing, isn't that a problem in bushfire zones? And the answer is no, because the Australian standard is all about keeping embers out from getting beyond the building skin in the first place. And I guess regardless, even if you had steel framing, once the embers get beyond that cladding, you're toast anyway, regardless of the framing, because the only barrier is really the thermal insulation and plasterboard. Also in Wye River, there's very limited services, so often you're looking at a wastewater treatment system, etc. And this building here, I mean, it captures the beautiful views out to the ocean like many do in Wye River. It's a very simple plan on the right. It's a great big all-in-one living space that looks out to a generous deck that wraps around 3 bedrooms, a couple of bathrooms. It was a very fun project to work on. This is some shots from the construction of that project in the factory. So we're building just panels here. These pictures are all about the floor panels. So on the top left there, you can see the whole floor has been broken up into, there's fine lines between that where that whole expanse of floor is divided up into cassettes. Usually we pre-line both sides and they're insulated with services integrated where practical. Often we'll leave off a strip of floor sheet to allow connections on site and to knit together across flooring junctions, but also as convenient points to attach straps for lifting. And you can see that on the right-hand side there where there's a floor cassette that's been landed with a bit of flooring left out the way to be sutured on site. In this case here, many of these wide rear projects, we're landing on steel bearers running across, and it's very important to coordinate closely with the structural engineer in these situations to make sure that the nature of the cassette breakup is going to gel well with those supports. And here are some of the wall panels going in place. We often try to finish them as much as possible. And in this case here, there was, in addition to the wall framing itself, the cladding was finished. And the way the detail here in the top left-hand corner was, I think the stud wall framing would sit on the floor cassettes, but then the cladding layer, the fibre cement, would continue past that edge. Sometimes in some of our earlier projects, we actually tried to restrict the panels to being only, say, 900 wide and being built in such a way that a couple of people could lift them. We wouldn't need a crane. This is an example of that methodology here. But I guess over time, we've started to opt more for maxing out the panel width that can fit on a legal truck, and then just have a crane on site. But this one here was quite interesting. Anyone who's been following us on Instagram over the years will note that some of our earlier projects had this kind of beautiful timber detailed external cladding. And that was partly, I guess it came from our origins of being this building from a kit of parts, so to speak, where we could have this similar detail of the horizontal boards. And when you attach those panels on site, you can stitch up the junctions by putting down a timber batten across the top to keep it all in place and to hide the gap. Shoreham. These panelised projects have got a lot of similarities, and the differences are that this one here is sitting on more of a conventional, or one of our more conventional footing systems. They're sitting on screw piles, I think. But I think in this case, the intention of the project, I really love the plan of this project, by the way. It's one of my favourites. Big fan of being able to break up program over, have to go outside to get to part of the house. In this case here, you have to go outside to get to the guest suite. And I think the planning, it was perhaps originally intended for it to be a modular build, but then whatever happened during the process, whether the roads turned out to be narrower than expected or the buildings grew a bit, ended up being a panelised build. Here we can see the production line of panels being made in the factory. So as Ben was talking about earlier, we can generate a whole suite of shop drawings that show every single cassette to be built. So someone sits there on the top left picture. There's a group of workers who are looking at the plans, building one floor plan, insulating, putting lining on the top, stacking it up on the right. Just keep going through until you finish them all. We end up with a nice neat stack of them, truck them to site, crane them in place, attach them together. Also, I just forgot to mention that another thing I like about this project is, again, we're using a dark timber cladding. And I think in this case, it was simply oiled timber, but it contrasts very well with the rich green, olive green texture of the surrounding site. This image here shows just a kind of snapshot of the documentation. On the top there is a floor cassette breakup. There's 3 panels in yellow there, and below you can see the red dashed lines indicating where those panels attach. The blue dashed line is indicating where the supports are in the subfloor. So you can see that each panel is sitting on 2 supports with a bit of cantilever happening, and then they're attached in situ. And this, when we were preparing this, we came across this. Someone on site must have taken a photo of a little sketch drawing to kind of communicate something. It's a hilarious drawing, but I think it communicates the final step, and that is putting a panelised ceiling or a roof in place. So here the idea is, it's either, I can't work it out, it's either a giant scorpion or a crane, don't know what you think, Ben, lifting the cassette to place, and then it is fixed to the sides of the wall panels. Very strict. This is a small one that we're just finishing up, and the constraint here is it's access is only by a right of way. It's a terrace that's built, boundary to boundary, so you can only bring things around the back. The right of way is tight, so it has to be a panelised build. And here we're taking advantage of the height there, so I think it's a bit higher than we normally achieve for a module, and finished to the extent of having building wrap on it.
Thanks, Andrew. All right, to finish off, I'm going to quickly look at another passive house project we built a couple of years back. So this is a project that was actually designed by Untitled Architects. This is a render that they produced. As you can see, there's some fantastic architectural forms here. So this made it quite a challenging project to build. And we were able to really push the limits of our prefabrication skills on this project. As I said before, I think this was also a project built to Passive House standard. But the solution for a project like this was to use a hybrid prefabricated approach, where we have both wall panels or 2D elements and some three-dimensional components or sort of mini modules. This is a drone shot of the site during installation. You can see the complex shape of the building in plan and various bits and pieces that we're installing. So the ground floor was actually on a concrete slab, and then we built ground floor walls, first floor walls, and a roof on top of that. This is a shot of, a typical shot of some of the wall panels that we were bringing to site. So these were fully wrapped and insulated in our workshop to provide the thermal envelope to meet the passive house requirements. An example of some of the more three-dimensional components of the building that we're bringing to site. Again, fully wrapped and insulated and then installed on site. Used another element. This is a section of the first floor, just illustrating some of the really interesting shapes of the components we had to bring for this job. So this is where we left that project. We were, as I say, building a thermal envelope under another builder who went on to do all the internal and external finishing on site. But yeah, you can see it all wrapped and sealed. And I think now that, just to end, I think now the project is getting close to completion. I think is getting published in various architectural media around the place.
And thanks, Ben. That brings us to the end. Thanks again, Alistair and Wood Solutions. Thanks for everyone who dialed in. Hope you're able to offer some insights to how we operate and the benefits and key considerations of prefab architecture.
Fantastic presentation, Andrew and Ben. Thanks very much. I might just get you to unshare your screen for a sec. I'll just share mine back. Yeah, some amazing work there. Yeah, clearly beyond people's previous expectations of what you can just do with offsite prefabrication. Just some great designs. Look, we've had some terrific questions here. I'm not sure we're going to get through them all, but we'll certainly work through as many of them as we can. I had a question here from Richard. For the volumetric and panelized prefab systems, how do you satisfy the requirement of the building surveyor being able to view the internals of the walls?
I guess I'll talk that. Yeah, it's an interesting one, and I guess you certainly need to have those consultants on board with what you're planning to do early in the process. But often we'll get an inspection undertaken in our workshop before these elements are delivered to site. But also, inspections are done on site as well. I guess often what we do is actually have an inspection from the structural engineer who's done the structural design of the project, and they're able to sign off on it as well.
Mm-hmm. And Nick asks, in cool climates, thermal mass is a primary element of good solar passive design. So how do you incorporate that with your prefabricated systems?
Yeah, it is a challenge. I think generally in places like Melbourne, we can get across the line by boosting up other aspects of the performance of the building. But if you go a bit colder than that, yes, there are benefits to including thermal mass, and it's something we have done. We've looked at doing buildings where we do a panelized build on concrete slab. So that's one way of getting around that.
Yeah, yep. I guess in the slides, I don't know if we really pointed it out, but we've done a modular project where we installed our timber frame modules and then essentially built the brick veneer walls around it on site afterwards. So that's an approach, but I guess that's not using thermal mass. But another point, at the moment, we're doing a job, we're about to start a job where we're installing some modules and then bringing a brick wall up through the floor of the modules once they're landed on site. So that'll give a thermal mass wall inside the building.
Hmm. Now, you would have expected to get some questions around cost, I'd imagine, cost comparison. So I've got a question here from Trent. Have you undertaken a cost comparison to a conventional site build project versus modular? I mean, obviously there are some time savings during construction, but curious to know if there are cost savings or not with these types of projects.
overall, it's pretty much break even with an architecturally designed project. It's like for like.
Yep.
I guess this is part of how we'd like to see the prefabrication industry sort of move forward. Is there tends to be the assumption, or people sort of look into prefabrication in the first place because they're looking at it as a way to save costs on their project. In other parts of the world where they're more focused on manufacturing approaches to these things, they actually see prefabrication as a premium product, a higher quality product, similar to how you get a car. You get a manufactured car, you wouldn't want to get a car that's just been built, in your driveway.
Most significant benefits to prefab over conventional construction are the efficiency of time, because we can simply build quicker in the factory. And also there can be that overlap of program where you can be finishing up something in the factory while you've started something on site.
Yep. And you guys did mention in the presentation about the benefits actually building regionally sometimes with these type of homes. So we've got a question here from Michael. What's the cost difference in transport between the 4.8 metre wide and the 5.5 metre wide modules if you were having to go, say, from Metro up to 150 kilometres from Melbourne?
I don't think it makes Metro to a bit of a distance from Melbourne is not much of an increase. When you go into state, it jumps up a bit. But I think, and the size of modules, I think, likewise, if you go from Metro from a 4.9 to a 5.5, I don't have a clear answer here. I can only give you, general terms, and welcome anyone to get in touch with us directly if you want some actual numbers. But again, I think you don't pay an awful lot more for a 5.5 module, but it's the extra cost might be in the pilot vehicle, etc. Yeah. Mm. But it's not a deal breaker. Basically, yes, there are increased costs, but in the grand scheme of the project, it's not really going to make a huge difference.
Yep. A question here just asking about the software you use internally for creating your module shop drawings. Is that something special, or is it a sort of standard type of software?
At the moment, we're using just Revit, Autodesk Revit. We find it ties into our architectural drawings very simply. But it's something that we're sort of constantly looking at. There's certainly more dedicated specialist software that you can use for these things. We'd love to potentially take those things up in the future. Yeah,
we've experimented with a few different kind of bespoke tools for this. At the moment, though, I think that's the future. And I think the dream is to get to a point where we can even start to introduce robotics into the fabrication. And for that, we'd need some specialist stuff. But at the moment, just with a general BIM environment, is good. I think a lot of we both come from regular architecture practices, I guess, and BIM's often a bit underutilized, but with what we do, it's very useful. You can give it's not like we sit there and model every single stick. We set up systems where we can have like a generic frame, wall frame, and we adjust the number of studs to suit, but then from that you can spit out the cut lengths, etc.
A question here from Charles. He just mentions it looks like you have to design for a highly rigid structure with minimum flex. So have you had any issues with window glass cracking or render cracking or tiles with when you've finished off areas?
No, I guess it's part of the design process we go through with our engineers, is ensuring that our modules, or not so much the wall panels, but the modules have that rigidity to be transported and installed. As I was sort of showing, we have that really rigid base to the buildings, and then we have additional OSB bracing that we put on the walls of the projects.
Yeah, we do simple things. I mean, I don't think the engineers go above and beyond to just double up thicknesses of beams or whatever for transport, but we often do just a few extra things which don't really make a huge difference to the cost, but make a huge difference to the rigidity. Things like, say, for example, the timber ring beams for a module might be spec'd to be a 300 by 45. Then the joists in the middle might only be 190s or so. We'll just have plenty of 300s lying around, so we'll use them as well, which forms a consistent bed depth when you're sitting on the truck, and it adds a bit of rigidity. It's just that bit above and beyond that makes a difference. But also we do details, like rather than just have brace board on a couple of key areas, we just wrap it all the way around. It makes detailing an awful lot simpler too.
Mm-hmm. In terms of some of those construction techniques, the question was here asked about, can you do cathedral type ceilings and other types of ceilings? Have you done them very often?
Yes, we can. we've got some projects we're looking at the moment. I guess in the projects that we showed, the modular projects that we showed, they were trussed roofs, so they were having a flat ceiling. But in the same way, you can build a pitched roof similar to how you build that on site, and fix plaster the underside of that to create a cathedral ceiling. But using a panelised approach, it's much more of a case of the sky being the limit, really. You can make the walls much taller and have a roof panel that just spans between them on a steep angle.
Yeah, you can do it. We often look at doing pitched roofs in just a single module, and the reality is, because of the heights, you've either got to have a lower pitch, which is not ideal often, or you just down the walls, there might be a lower clearance there where you might integrate that and make it more where joinery goes, etc. Or of course you go to a double module approach, like some of those examples where you build a double height space, or you might build the roof as a separate module that it comes onto the main body of the house below.
Look, guys, we've got a few more questions, but it's right on midday, so we do need to finish up. So I'd like to thank you once again on behalf of all the attendees. It was a fantastic presentation. I do remind people that the presentations are recorded. So if you want to go back and have a look at this again or any of the other presentations, just go to the Wood Solutions website, click on that webinars download section, and you can access those. In terms of webinars coming up, we've actually got one this Thursday. So Andrew Dunn is going to be talking about cost planning for assisted living and portal frame type structures. So if you're interested in those types of applications, certainly tune into that one. And then next Tuesday, Tuesday the 22nd, so our bi-weekly webinars, we have Professor Jeff Borton talking about building to resist in high wind cyclonic force areas and using Cyclone Seroja as a case study. So Jeff's a real expert in these areas. If you're interested in building in high wind areas, this will be certainly one to see as well. So thank you once again, everyone. Thanks, Andrew and Ben, and we look forward to welcoming you at some more webinars in the future.